Alrighty, y'all. So in this video, I'm going to go over the Bondline formula homework. So let's say I give you a Bondline formula, right? So Bondline formula is pretty much like Lewis structures, except we don't explicitly draw the carbons or hydrogens. So let's say I have a molecule that looks like this, right? There are carbons and hydrogens in here, but we just don't draw it because oftentimes when we're looking at larger molecules, it's really repetitive to write the elements C and H for carbon and hydrogen over and over again. So in this version, it's just kind of hidden in there, and we have to somehow implicitly figure out that in this particular bond line, the molecular formula or the amounts of each elements would be C4 for 4 carbons, H8s, 8 hydrogens, and 1 oxygen. Right, so I'm going to show you how I figured that out in this first example. So in step number 1, I need to identify all of the carbons. So all the carbons are at the vertices or vertex or end of the line segment. Right, so what I mean by that is that at every single corner, right, here's a corner here, here's another corner or a vertex, that's where the carbons are hidden. If there's already an element here at the end, there's no carbon there, the space is being taken up by oxygen. Additionally, at the end of a line segment, so here and here, there are also carbons. So that's how I figured out there are 4 carbons. The hydrogens are a little bit trickier. So to identify the number of hydrogens, I need to recognize that carbon has 4 bonds. Or carbon is always connected to 4 other elements, right? So looking at this carbon in red, notice that there's already 1 bond line connecting it to this second carbon here to the right. So there's 1 line coming out of this carbon, but remember that carbon has 4 bonds. So therefore, it's missing 1, 2, 3 elements that it's connected to, and that's where the hydrogens are going to be, right? So there are 3 hydrogens connected to this carbon on the far left. This second carbon, there's already 1, 2 from the double bond, 3, 4 lines connected to this second carbon, so it does not need any hydrogens. This third carbon has 1 line, 2 lines coming out of this third carbon, so it needs 2 more to make 4 bonds. So therefore, it's going to need 2 hydrogens. This last carbon here on the far right, notice that there's 1 line coming out of the left, so it's going to need 3 more hydrogens, totaling up to 4 bonds total, right? So that's how I figure out that in total, I have 8 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, H8s. And notice that I put oxygen last. Oxygen is just identified here in terms of the symbol O, right? So in my third step, there's an order into which I write my molecular formula. So when I write my molecular formula, I'm going to count the carbons I have first, then hydrogen. So that's why it's C4H8, and then oxygen. If I don't have any oxygens, I'll skip it. Then nitrogen, then phosphorus, and then any other elements last, right? And when you get here for the other elements, it doesn't really matter the order so much, at least not for the purposes of this class. So go ahead and pause the video and see if you can figure this one out, and I'll give you the answer in a little bit. All right, so for this particular problem, right, It should be C6H8O. All right, so hopefully this first answer helps you out a little bit. And then also as a note for the second problem, right, be mindful of when the H's are written, you're also counting those as part of your total, right? So notice that this is H11, right? Then O, then N. So I'm counting them following this order. So hopefully that helps with your Bondline formula homework. Feel free to send me an email if you have any questions, and I'll get back to you as soon as I can.